Now we are gonna move to Glenn Jackson from Agricom. Agricom is the sponsor of this session. So Glenn, all yours.
Thanks, Pablo. Can you hear me?
Yes, I can.
Excellent, thank you. And good morning to everybody. My name's Glenn Judson, and this morning I'm representing Agricom, and we are very pleased to be sponsors of this next section. Just to give you a little bit of background on Agricom, we're a proprietary seed company providing both products and innovative solutions to New Zealand's pastoral farmers. Our portfolio is quite wide with many temperate species and cropping options, and I guess this range allows us to impact not just on the forage production and quality, but it also allows us to provide biodiversity and environmental functionality, which are really becoming critical characteristics of modern pastoral farming. And really, it's this morning I just wanted to give you a little bit of update on a product that fits in that system or in that category quite nicely in terms of environmental functionality, and that's our product, which is Ecotane. And Ecotane is a environmentally functional plantain, which reduces nitrate leaching from the animal urine patch using 4 different mechanisms. And so I'm just going to take you through a small presentation here. So Ecotane is a grazing herb. It's something that you would add to a pasture mix, or you can grow this alone. It's a member. It's a Plantago lanceolata, so a member of the Plantago species, and it's been bred for upright growth and winter activity. So looks very similar to what you might find as a colonizing weed, but has certainly undergone a number of cycles of selection to be useful in a grazing setting. In terms of its functionality, one of the biggest problems, particularly in pastoral agriculture, is the fact that we have nitrogen leaching out of these systems to the environment. And while nitrogen is not the only issue that impacts water quality, it's quite a key one. And the reason it's a key one is if we look at a typical farming scene, particularly in New Zealand. The other things that do affect water quality being phosphate, E. coli, and sediment. These tend to be relatively well controlled, as we see in this photo where we've fenced off the waterways and excluded stock from access. And that does have quite an impact on, as I said, phosphate, sediment, and coli. But what it doesn't do particularly well is have any effect on the nitrogen leaching out of these systems. And that's because nitrogen is moving straight down through the soil and typically not across the soil profile. Up to about 90% of the nitrogen, which is actually escaping these production systems, come through the urine patch. And I guess that's why the urine patch is so important, because, for example, a dairy cow will graze about 140 square meters of pasture a day. And will deposit approximately half of the nitrogen that she consumes into urine patches, which cover just 3 square meters. And it's this concentrating of nitrogen into these patches of high nitrogen concentration, and some of those can approach the equivalent of 1,000 units of nitrogen. And so it's from these urine patches where we get most of our leaching, as plants aren't able to take up too much of that nitrogen, and as water moves through the profile, we lose that. So in terms of the functionality of Ecotane, that functions in 4 ways to reduce nitrate leaching from the urine patch, because essentially if we can control nitrogen leaching from the urine patch, we can control a large amount of the nitrogen leaching off pastoral farm. So the 4 mechanisms through which Ecotane does this, we've referred to them as dilute and delay, reduce and restrict. And I'm just going to take you through very quickly what's happening in each of those mechanisms in terms of the reduction in terms of nitrate leaching. And let's do that in a way that we're probably more familiar with in terms of a nitrogen cycle. So the dilute and reduce functions, they occur in the animal. Essentially what's happening is that we're getting a reduction in the amount of dietary nitrogen entering urine. So that's N partitioning. I'll show you a little bit of data on that in a minute. And the other one is a dilution. So the nitrogen which is getting into urine is being diluted by an increase in urine volume. That's occurring because Ecotane is typically a wetter forage, so water intake is higher, and it also has quite a strong diuretic effect, which means the animal is actually releasing more water to urine. So that's the dilute and reduce animal-centric mechanisms. The other two are soil-based. A delay in the conversion of soil ammonia through to nitrate, biological nitrification inhibitor, which is in the urine. So that's the delay function. And then the restrict function, a little bit less known about this, but we think from root exudates, the plant's actually changing the way that nitrogen cycling in the soil. So a little bit of data on that. So some work here from Dairy NZ showing as we increase the percentage of plantain in the treatment, we get a lower proportion of the total nitrogen consumed going out in urine, more coming out in fecal material and more coming out of milk. So it's a change in the partitioning of nitrogen away from urine, which is where we have the greatest risk of leaching. In terms of the diuretic, we've discovered this by putting animals indoors and collecting urine off those over time with different diets. We've done a number of different breeding lines and commercial products in terms of the diuresis. Here we are offering animals feed where they are consuming 5.5 litres of water, and that comes in on the feed. You'll see there at the grass, the partial water budget says that in a grass diet, consuming 5.5 litres of water, and the urine volume is 4 litres of water. Water loss to fecal material and also in breath and other losses will account for the difference. You'll see there that some of the breeding lines, particularly the two cultivars that make up Ecotane, we're getting over 5 litres of urine coming out, and therefore for the same water intake we have increased urine volume, which is the definition of diuresis. Those two factors, less nitrogen in urine and a higher dilution rate, lead us to common observations of differences between grass and Ecotane diets in terms of urine. So it's very hard to get your samples mixed up. So on the left-hand side here is urine from cattle grazing ryegrass, and on the right, a Ecotane diet. There are a number of different plantains about, and here's a really good example of both the colour change and the nitrogen concentration from different plantains. The one that is found in Ecotane is labelled there as G, so it's the lightest colour and the most dilute in terms of nitrogen. Interestingly, we will need to look at a lot of our breeding lines and put them through some of these tests to ensure that we are maintaining the functionality in future breeding lines. The other two examples, or the other two mechanisms through which Ecotane reduces nitrate leaching from the urine patch. The other one is delay, and this is essentially creating a slow release urine patch. And this is some work that we've done putting urine from animals grazing either ryegrass diets or Ecotane diets onto soil and looking at the speed at which urinary nitrogen is converted to nitrate. So on the left-hand side graph here, the red line represents the nitrate buildup from ryegrass urine, and so over about 21 days we get most of the nitrogen that urine patch created to or converted to nitrate. And on the right hand side B is just showing the decline in terms of soil ammonia, so one's being converted to the other. If you looked at the green line, this is the agritonic animals grazing agritonic, and you'll see there's certainly a delay in terms of the amount of nitrate which is building up up over time. So we see that as important, particularly in soils which are quite leaky, and if we can hold more of the nitrogen in the ammonium form, the non-leachable form, we think that that'll give the plants just a greater chance of picking up some of that nitrogen. The final mechanism in terms of Ecotane is actually the restrict function, and this is where we get the same process in terms of the reduced nitrate buildup, but this is happening regardless of the or outside the urine patch and regardless of what those animals have been eating. We think this is happening from root exudate. So some work from Rasheen Woods, where using normal animal urine in a lysimeter setting with Ecotane making up about 42% of the sward, and measurement there was a 45% reduction in terms of leaching from a urine patch over a 12-month period. Interestingly enough, there have been some other lysimeter work done, and that's variable, but the numbers in terms of reductions have been quite significant. There's actually only one study where both Ecotane urine has been used in terms of putting that onto the lysimeter, so we get all of the four mechanisms: the reduced amount of dietary nitrogen making it into urine, the greater dilution, a delay effect in the urine patch, and this restriction in terms of conversion in the soil, and the number there is quite impressive in terms of the reductions out of a lysimeter. There's a little bit of work going on now in terms of whether we can scale that up to farm scale and what that looks like. Typically, we would expect at farm scale those reductions not to be quite as high, but we're interested to see if we could possibly halve the amount of nitrate being leached out of a farm system by employing this as a technology. So in summary, Ecotane's a pasture herb that we can put into many of our pastoral settings. It seems to be a powerful tool in terms of its ability to reduce nitrate leaching from the urine patch. So listen, again, just to reiterate, this is really exciting for Agricom to be sponsoring this session, and we hope you enjoy the rest of the conference. Thank you.
Thank you very much, Glenn. I appreciate that. I appreciate the support of Agricom. Agricom and the pastoral livestock production at Lincoln University are working together. So, and we'll keep looking forward to do some more interesting stuff. Glenn, thank you very much.